Satellite refers to the term for an object that's moving around another body under the effect of their mutual interacting forces. For example, electron is satellite of nucleus, Earth is satellite of Sun in broader perspective. But here we are considering the satellite that's natural, like moon around the Earth, and artificial satellites INSAT 1A, 1B, that of Indian make. So these satellites obtain the centripetal force from the gravitational force between Earth and themselves. When these satellites revolve around the Earth, their velocity would be known as orbital velocity. It's given by root GRE. We can derive it by using the gravitational force equal to centripetal force. We get this relation. The orbital velocity shall be exactly tangential, like this. This is orbital velocity, the radius of the orbit, mass of satellite and that of the Earth. Orbital velocity does not depend on the mass of the satellite. It depends on the mass of central object and this radius. If the orbital velocity is considered for Earth satellite, it comes out to be root GRE, about 7 km per second. But this formula is applicable for the orbit having a smaller radius. The accurate formula is going to be root 2 GME upon RE. The escape velocity is root 2 GRE. That means the ratio between the two, that is escape and orbital velocity, will be root 2 is to 1. That means if the satellite is orbiting and the velocity is increased to 1.414 times, it is likely to escape the orbit. Time period is given by 2 pi upon omega, and omega could be written as V upon R. So this is VO upon R. If we solve this, we find this is 2 pi root R cube upon GME. Had it been some other planet in place of Earth, we would write the mass of that very planet. For Earth, this time period in closer orbit comes out to be 2 pi root RE upon G. That's roughly about 84.6 minutes. If the radius is increased, time period of the satellite increases. Here one thing is very remarkable. Once you say that this time period or the velocity of the satellite in the orbit depends on the radius. In both the cases, you find the radius is important for time period and velocity as well. If some satellite is going on in the orbit and the other is behind it, and both the satellites belong to two different countries having not very good relation with each other, and the satellite that is lagging behind has an ambition to supersede or just overtake this satellite, it is just impossible in the space. Why? If the satellite behind will try to increase the speed, by changing the speed, the radius of the orbit will automatically change. So it's not going to be in the same orbit. The orbit will not be same anymore, and the condition possibility of the collision or overtaking will be just impossible. So you may not think, even in dreams also, that two satellites have crashed together, because soon as the velocity will be increased, the radius of the orbit will automatically change.